No, huh? All right, we should get started. Okay. I believe for last class we finished up everything. Oh, yeah, I'm already recording. We finished up everything for group work or for 4.1, but I never gave you guys time to do the group work. Oh no, wait, I did. I did give you guys time for group work, didn't I?
Yeah.
Okay. So never mind. Let's move on to 4.2. I am lost myself. Okay. So we're going to continue on with our study of exponentials, the next group of functions that we were supposed to study for the class. And we're going to start learning how to graph the darn things, right? So before we start, I want to get I want to do a quick review of some stuff. So let me rewrite this. All right. Everybody probably remembers this. So there are a couple things here. There's that, there's that, there's that, that, and that. And these did specific things, right? So that plus or minus the very front one. What did that do?
Flip or shrink and stuff like that.
Well, which flip?
The negative.
But what? So what direction was it? The flip across side to side or flip up?
Oh, up and down.
Right. This was the vertical flip. Right? The A did what?
Stretch or shrink.
Right. What kind of stretch? What kind of vertical or horizontal?
Yep, vertical.
Vertical, right. TCH/compression. All right. Actually, let me add in one more here. What did this plus or minus do?
Horizontal flip or stretch or shrink.
Right, this is the horizontal. The horizontal flip. The B.
Was that the horizontal vertical stretcher compression?
Right. The H. What did the H do?
Oh, wait. Oh, that was go left or right.
Yes, that was the what's called the horizontal shift.
Mm-hmm.
Right? And then lastly, that K.
That one you go up or down.
Right, this was the vertical shift. Got it?
Mm-hmm.
Okay. So originally, the ones that really, okay. The ones that originally the ones that we were looking at maybe the last chapter, right? Were particularly this one, this one, and this one, correct? So we only cared about the vertical flip, the vertical stretch or compression, shifting it left or right, and then moving it up and down, correct? So now we are going to add two more. Those two, the plus or minus inside and that B. Actually, me not liking how congested that looks now. So we're going to add these two. We're going to add the B and that plus or minus up front. This time around, it'll actually do, we actually have to take that into account. Okay. The rest of the stuff works out the same way. So, here I give you guys two graphs. And these two graphs are for f of x equal 2x and f of x equal 1/2 x. So specifically, what I want to do is I want to look at these two things. So this one has a 2 and this one has a 1/2, right? And this one's shooting upward in that direction, and then this one's shooting upward in the other direction, right? Or equivalently, if one of them, so if the 2x one, if the 2 to the x is increasing in that direction, the g of x equal 1/2 to the x is decreasing in that direction. And we'll learn why that is in a little bit.
Can you repeat that? It's like too muffled or...
Yeah, I want to see whose microphone that is. So
I'm turning mine on.
So it is not yours, Brittany, because it's still happening. We might need to, I think it might be Madison's. Who else has got a mic that's on?
Can you turn them all off? And if we want to participate, we can unmute.
That works. How about that? So let me mute everyone really quick. And as you need a question to be answered, go ahead, unmute yourselves and then remute yourselves. Does that make sense?
Yep.
Okay. Muting.
I'll clean it.
All right, so what I just did was I muted everybody. So because we can't find out whose microphone is the one that's actually making the, giving the feedback. It sounds very muffled. So as you need to ask a question, make sure you unmute yourself, ask the question, and then remute yourself. Does that make sense? So somebody else just came into the room. I muted everyone because somebody's microphone is providing feedback. So what I want everybody to do, I muted everybody just now. So what I want everybody to do is if you need to ask a question, go ahead, unmute yourself, ask the question, and then remute yourself. I know that's sounds very sort of contradictory to what we want to do, but it seems like it's becoming a little bothersome for everybody else. Otherwise, you can just ask it in the chat box. I still have that open. So any which way you guys want to do it, sounds good to me. Cool? All right, so let me get back to this thing. So as I was mentioning, right, we have the two functions here, f of x equal 2 to the x, and then g of x equals 1/2 to the x. So notice the behavior of each one. We'll study why this does, both of these graphs do these, right? In this chapter, by the time we're done with this chapter, we'll know why the graphs are doing what they do. Yeah. Now it sounds like I'm talking to myself. So, this one, if you go toward the positives, is increasing, right? But the other one, as you go to the positives, big positives, it begins to decrease, right? And therein lies a pretty important bit of information. If your b value, so in this case, the b that I'm talking about is that 2, right, is greater than 1, then your exponential function will be increasing. And then likewise, if your b 0, b 1, it is decreasing. So if you guys look at the b for this one, right, it is 1/2. That is the telltale sign of something that will be decreasing. Cool? Okay, so like I said, all the rules from way back in the day still work out. So I'm going to graph 2 to the x on this graph. So we know we're going to plug in just the x values that are here. So 0, 1, 2, 3, 4, 5. We're just going to go ahead and graph them out. So if we plug in, so here's the original. We're going to do the good old original. Actually, let me color code them a little differently. So the black one will be the 2 to the x. So 2 to the 0, anything to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. So let me put those coordinates down. 0, 1, 1, 2, 2, 4, 3, 8. Cool? Those are the same points that we have up here. So I'm just basically copying what's there. So now, -1, because of the things that we were doing yesterday, we have, so this point right here will be, I'm running out of space here. I don't want to make it look too nasty. -1, 1/2. So some of you guys might be asking, how is that 1/2? So if we plug it into 2 to the -1, right? We know that from yesterday, or no, Monday, that is true, right? And that's how we get our value here.
I have a question. Why is it 0 and 1?
So if we do 2 to the 0, right?
Yeah.
The original, so the rule that we're using there is anything to the 0 power is always equal to 1.
Oh, okay.
Doesn't matter what it is. So this is automatically, the output is 1.
Okay.
Got it?
Yes.
Cool. Okay, same thing as we go farther down. So this point is going to be -2, 1/4. fourth. And that one is, if we do 2 to the negative 2, that is equivalent to 1 over 2 to the 2. And 2 squared is 4, so 1/4. These are all the rules that we were using. Not all of them. At this point, I think we've only used 2 rules, really. I'm going to leave this one here. I'm actually going to put it down below. 2 to the 0 is always equal to 1. Okay. And then it'll keep going down. So that point is going to be -3 1/8, right? Same work as we did in the previous 2. So we need to do 2 to the negative 3rd, which is 1 over 2 to the 3rd. And 2 to the 3rd is 1/8. Yeah? And then it just keeps dropping down farther and farther. I'm not going to do the math for them. I think we've killed it with the ones that we've done already. That's cool. Okay, so we go back to kindergarten and connect some dots. So that's how we end up graphing it. So essentially what I did was figured out the points that go in there. Depending on what your function is, you'll need to graph whatever you need for the base that's been given. So in this case, the base is 2. So I was doing it for 2. The same workup or the same work can be done for 5 to the x, 7 to the x, 3 to the x. All of those are equivalent. Cool? Okay, like I said, if you guys need to stop me, stop me. I'm sitting here watching the market fall and the president speak, so not doing anything at all. Okay.
Wait, so
Yeah.
so just for confirmation on these, we're doing the one for FX, right?
Yes, this is
Eh,
just FX one for now.
Okay, so then the reason why you're doing 2 to -1 is because the x is -1, so you're putting that on top, and then 2 is equal to just 2, so it's 1 over 2 to the first, or 2 over 1, or
Which one are you
2.
talking about?
The first one, so you got 2, then you got a power -1 equals 1/2 square. It looks like ones on top of that too
You're
as
talking
well.
about this one, correct?
Yes, I'm saying that the reason why you're doing that is because 1/2 is equal to just 2, so that's why it's 2 with the 1 up there, right?
Right. So let me do a flashback really quick. For 1. Let me make this small. So you guys remember all those rules?
Yeah.
Yeah. We are essentially using the negative powers rule. We are essentially using, whoa, come on.
Actually, it literally looks the same too, so I can see what you mean. You got the, yep, it literally looks the same.
Yeah.
You
So
got,
we are using this rule right here
perfect.
to graph it. So just a quick recap. If you have a negative exponent, that's equivalent to 1 over the positive exponent. So that's how I've been getting those points. That's how I've been getting these points right here. So I've been plugging in, let me zoom in one really quick. My x value is -1, right? So then that's been plugging in up there, right? And then same thing here. My value here is -2. So that's what I've been plugging in up there, right? So on and so forth. Okay, my thingy is acting up. Okay, so yeah, my app crashed. Let me open it up again really quick. My tablet is being a butt. Okay. All right. We back on?
Yep.
Yeah, you're back on.
Okay, thank goodness. I don't know why out of nowhere my note taking app just like crashed and it just closed out on me. Thankfully it didn't disconnect to the streaming
Audio.
Yeah, the audio. So notice how, like I said, -1 was my X, that's what got plugged in. -2 was my X, that's what got plugged in. -3 was my X, -3 was what got plugged in, right?
Yeah.
How this works out everywhere, right? 0 was my input, that's what got plugged in, right? Actually, let me do the rest of the maths here. 2 to the 1 is equal to 2. 2 squared is 4. 2 cubed is 8. So the same work happened over all these, right? So 1 was my input. That's what got plugged in. 2, 2, 3, 3, and so on and so forth. Now, what I want to move on to is the other two. What do you guys think this one is? What do you think that plus? Yeah, what do you think that +3 will do?
They're gonna shift all the points up 3.
It'll shift up 3, exactly. Does that make sense?
Yeah.
Mhm.
So what I want to do is this. Everybody have that little math that's there? I'm going to erase the math. It's going to show up on the recording, so you guys don't have to worry about it like completely disappearing. It is there. I just need to get rid of it because it's now going to become very cluttered.
Mm.
So we are moving everything up +3. So I'm going to do the red marker. So this point right here moves up 3. So it's going to be 3 1/8. Does that make sense? 1, 2, 3 1/8. So that point will now be up here. Right? The next point moves up to 3 1/4. So 1, 2, 3 1/4. Make the point's nice and big for people to see. The next point is going to move to 3 1/2. Right? 1, 2, 3 1/2. The next point is going to move up to 4. The next point moves up to, is that 5? Next point up to 6. Oh, sorry, 7. Next point we can't entirely put because we ran out of space. So we have enough points there to at least do a
graph.
graph.
Do you know when the homework for the last chapter and this chapter will be up?
Hopefully by the end of today. I've been looking at thank you for reminding me. Let me finish this example, and I'll so to answer your question really quick. I will hopefully be doing that later on today. I'll be putting
Perfect.
a fair amount of the lecture question things up so that people can turn them in online.
Sweet.
That's just tedious stuff. I need to sit down for at least like 2-3 hours to do them all.
No, it's no
Yay,
problem. Take your
homework.
time. There's no rush.
No, I know there's no rush. Like I said, I think I said it in an email. I'm not going to make too big a deal about the deadlines or the due dates.
Okay, perfect.
Just, keep yourselves on pace. Don't fall too far behind. Yeah, I'm just going to say that.
No problem at all.
Cool. Okay. All right. So we did. I screwed that one up. I'm going to do this. I meant it for it to be under red. So you guys see what ended up happening here is I'm going to use my space pen. You guys see that there's an asymptote there, sort of, right?
All right on 3, huh?
At 3, exactly, right? Right where, if you look at the one below it, the very
same one,
the
0.
OG, right? That one was at 0, right? So how big do you guys think this space is right here?
Is it 3?
Right. It is exactly that amount of shift.
Which is why it's +3, because it's 3 in between those points.
Exactly. Got it? So now.
And it's the same thing for the -3, so you move down 3 instead of going up for that one.
Exactly. So then this one would move down 3. Right? So we automatically now, we don't even have to do very much. We know that whatever this shift is, right, whether it be +3 or down 3, those two asymptotes have to follow it.
Okay.
Right? So we can automatically say we know where our asymptote's going to be.
At -3, which would be 3 in between again.
Right. Make sense? And now come the rest of the point. So we know that this one, it's got to be, so the -3 point has to be sitting right above it. The -2 point has to be sitting a little bit above that. Has to be about a half above. And notice how it sort of works out if you know where the asymptote went. Right? And now here is where it becomes a little bit more difficult, but not too much. 1, 2, 3. So this one's going to be here. The next one, 2, 3 is going to be about right there. The next one after that is going to be 1, 2, 3 right here. So you guys see how this is working out? It's not any, come on. I'm trying to make my pen a little thicker so that okay, so it's not anything different from what you guys remember from before. It actually transfers over very readily. Now we're just gonna actually, let me make my red one a little thicker too. There we go. And then likewise, what happened here?
Be -3?
Right, this would be -3. So you guys see how It's a little easier this time because we have these asymptotes that are down here, right? Okay, we good? We cool?
Yeah, so it kind of does the same thing in the bottom example, right? So you get the 1/2 x, which would do the same thing essentially that you did on this, and then you got the x plus 3 on 1/2 on gx. So that's just telling you to move up 3, and then on
Okay, close, close. So this case, we have a +3 and a -3 here, right?
yeah.
What do these +3s and -3s do?
Would that be I have no, would you add the two values for, would you add the value for x and then 3 and then get your value?
Not quite. What'd they do before?
They told us, well, it reflected the y value, so you moved up 3 on the past one and you moved down 3 for the other one.
That is correct, but notice the 3s in this case, right?
Yeah.
They were outside of the x, right? What happens when they are together with the x?
So are the x values going to shift left or right?
Exactly. So these are going to be your shift left and right.
Oh, okay.
These 3s are your shift left or right. And they work out the same way that they did previously. So what I'm going to do first is I'm going to graph 1/2 x. Okay, so no matter what, the first point that we can easily get is that 0, 1. And the reason there, the same one from before, 1/2 to the 0 power is always going to be equal to 1. Anything to the 0 power is going to be equal to 1. The next point, that point is going to be 1, 1/2, right? And the reason there, 1/2 to the first power is always just 1/2. Anything to the first power is just itself. The next one, 2, 1/4, and the reason there is 1/2 squared is 1/4. Actually, it's going to be 1/2 squared, which is 1/4. Then after that, 3 1/8. And the reason for that one, 1/2 cubed is 1/2 to the third, and that's where we get our 1/8 from. And I'm not going to graph the rest. I'm not going to do the math, but it's similar all the way down.
Are they not negative?
These
The
are not.
Wi-Fi?
So I think what you're going to be referring to is this other side.
But isn't the half, the fraction, 1 and 1/2? Aren't you going down on the y-axis? So wouldn't it be a negative 1/2 or no?
No.
Okay.
So you're talking about 4, right?
Talking about 4. Where?
Well, what x value are you talking about?
You have 1 here, and then you have 1.5. So isn't that a y value? Oh, I can't mark the screen. I'm like waiting for you to like, yeah, that one.
Yeah, this one.
Mm-hmm.
These are not negative because I'm plugging in +1, +2, +3, +4.
Oh, okay. The last number was okay. Got it.
Yeah, let me go. Let me actually 1. Let me write everything that my eraser just grossly erased. Okay, so this 1, right, is supposed to be that 1. It's the exponent. The 2 is that exponent. The 3 is that exponent.
Oh, I got it.
Right?
I got it.
I forgot to, I didn't really, the black one is going to be the 1/2 to the x. We're going to be graphing that one.
Got it. Okay. Thank
Okay.
you.
Okay. This one on the other end, though, is nice and wild. So the next point will be this point right here. So this is going to be -1, comma 2. Okay. And the math behind that one is we have 1/2 to the -1 using the same rules that we were using before. This is going to be 1 over 1/2. So it's 1/2 divided by, or 1 divided by 1/2. And that is 2. Hence the reason why your y value here is that right there. And again, same work goes on here. So it's going to erase half of everything I did. God dang it. -1. Hopefully everybody can read that. So the same work here, right? This -1 that's down here is that exponent. Okay, your next point is when you plug in -2, and that is going to end up being 4. So this point is going to be -2, comma 4. And the math for that one is 1/2 to the -2. Same rule as before, 1 over 1/2 squared, which is 1 over 1/4, and that is 4. I should actually start color coding these, shouldn't I? Since it's getting nice and wild. Okay. Stop me if you need me. And then lastly, we're doing the input of -3. That point is going to be, hopefully you guys see a connection here. It's going to be, oh, come on.
So you're essentially just doing the same thing basically you're doing on the other ones.
Right. So the work for this one, let me do the work for this one really quick. 1/2 to the -3, same as before. Uh, 1 over 1/2 cubed, which is 1 over 1/8. And if you do the division, all that stuff with it, you get back 8.
So just to walk through real quick,
Mhm.
so since it's on -3, that's why you have -3 up on the top. So it's 1/2. Basically -3, and then it moves over, becomes essentially just you remove the negative and then you square it to get 1/1/8, and then you get 8.
Yep.
After doing the math.
Yep.
Okay, perfect.
Okay. Whoa. My computer's being wacko. Okay, there we go.
So when you're actually doing some problems on these,
Yeah.
how do you find the actual values in order to actually solve the problem?
Well, what do you mean the actual values?
So I noticed that you got all these values over here. So like an example would be like you have -2 and 4 down there. So how exactly did you like? Did you just take that point randomly and just say, you know, we're going to solve a problem for this, or did you?
So for these, I see what you're saying. For these in particular, choose the nice x value. So in this case, for all of these for all of these exponent graphing ones, you don't have to choose more than you shouldn't be choosing. Let me put it that way. You shouldn't be choosing other x values that aren't sort of like whole positive or negative numbers.
Okay.
Does that make sense? So
Yeah.
plug in 0, -1, -5, -20. That'll get you at least exact values.
Okay.
Much easier to work with than plugging in like a half.
Okay, that makes sense.
Does that make sense?
Yeah.
So you shouldn't be plugging in anything that's not integer values already.
Okay, so like, so for the first lecture question down below, you could do like one what would be example? So let's just say we wanted to solve that one. So you just say like you could use the value of just like on the x-axis +1, that would work.
Right.
Okay.
So don't do the lecture question yet because I haven't finished up
Yeah.
yet.
No problem.
There's tons of connections here. So I want everybody to look at. I'm going to shift up really quick. Actually, let me finish connecting the dots really quick. So I'm going to get rid of I'm going to leave the points, but I'm going to get rid of the math for how I got the points. Ah, dang it. Let me rewrite these points right here. -1, 2, 0, 1. Okay, so we've got some points here. I'm going to take it back to kindergarten and connect the dots. Cool. Make this dot fat enough so it'll actually, there we go. Okay. So now, let me actually finish up this example really quick before I blow your guys' minds. What is, so this is going to be my red one. What does that +3 do?
Shifts it left 3 units
Why left?
because it's +3.
Right, it's +3. So then this point up here shifts left 3 units. So 1, 2, 3. So now my point's there. Right? Where does this point go?
To the left 3 units.
The left 3 units. Everything gets shifted over. 1, 2, 3. 1, 2, 3. Did that move the asymptote at all?
Nope.
Nope. The asymptote actually stays.
So essentially, you're just once you do all the work for the first one for f of x, everything else kind of solves itself.
Exactly. All you got to do is follow whatever the equation says to do, right? Either a shift left or a shift right. All right, there we go. I should actually make it a little thicker so it stands out. I am so trying, you guys, I swear. I know it looks all jagged and stuff, but the idea is still there. Okay, last one. What's that -3 do?
Moves over to the right 3.
Moves over to the right. So it still works out the same way. Whatever the sign is, opposite of the sign, that's the direction you move it in. So 1, 2, 3. 1, 2, 3. 2, 3. And kindergarten, connect the dots. Actually, let me change that one. How are we feeling about this stuff?
I'm feeling pretty comfortable.
Awesome. Okay, so here's the thing I want to blow your minds with. You guys ready? So I want to move back up here to this one. And I am going to, so what I want people to do, I'm going to add a highlighter here. I don't know where my pink one went. There we go. Okay, what I want people to do, what's going on with these points right here? So there's this point and this point. There's this point, this point, this point, this point. That one, that one, that one, that one, that one, that one. What do you guys see?
I see, and what do I see on each of those points?
Right.
So it looks like it's 3 because the point is 3. On the 3 with 1/8. I'm assuming that you did where is it? It was 1/2 originally, so you did 2 to the 2 cubed, which got you 1/8. Is that what you did?
Kinda.
You're talking about the fx equals 2x, right?
Well, for both. For fx equal 2x and fx equal 1/2 x.
Is x the negative exponent on the first one?
Right?
And then on the second one,
Wait, no, sorry. The first one is not the negative exponent. The first one is just the regular good old, let me actually. So this one is that one, and then this one is this one. What do you guys notice about the y values for both? So I highlighted pairs of points in each graph.
uh-huh.
You're just flipped.
Exactly, they're flipped. Does that make sense?
Yeah, so is it because, so why did they flip?
Yeah.
So one of those rolls. That we learned back in the day.
It is one of those rules. So how about this? I'm actually gonna move it over here. So what is 2 to the 1, or sorry, 2 to the negative 1? That is also equal to?
So it'd be we just did these 2 over 1. Would it be equal to 2?
Mm-mm.
1/2.
Right, this is the 1 over 2 to the 1, which is 1/2, right?
Oh yeah, because you lose the negative and it become just 2, 1, and v2. Okay.
Yeah, I think that's what you were trying to say. 2 to the negative 2.
It would be 1 over 2 squared, which would be 4, 1 over 4.
Right. 2 to the negative cubed.
It'd be 1 over 8.
Right. 1 over 8. Right. 1 over 2 cubed, which is 1 over 8. All right. Here's the kicker. You guys ready?
Yeah.
2 to the negative x. What should that be if you use just the graphing information that was given above it?
It'd be 4.
So that negative, so this negative something added in, what does that negative do?
Doesn't make all the x values negative.
Yes, but according to the stuff up above it, though.
Does it make it a fraction?
A horizontal flip.
Right. Now, see, this is what I'm saying. That negative is that negative right there, for the horizontal flip.
So that's essentially why it flips over to become the complete opposite of what you had on the left compared to the right graph on that one example you were showing not too long ago.
Yep. So, turns out I'm not done yet.
Oh, yay.
I'm going to use the same rule that we were using above it, right? So then this is also equivalent to 1 over, my pen's acting up now, 1 over 2, oh boy. 1 over 2 to the x, correct?
Yeah.
Yeah.
Which is also the same as 1/2 to the x. I guess you guys have gone quiet in amazement. So,
Okay, if you say so. Got it.
how about this? How about we go, I actually missed a step in here. Let me do 1 to the x over 2 to the x. And that is 1/2 x. So now, if you look at this math, this voodoo math that I just wrote down, I swear to you guys, my pen is now acting all.
It seems like essentially it just becomes 1/2 because you're just flipping it from a
Right.
negative to a positive, correct?
Yeah, so if we take a look at all the math that goes, let me add this in first. 1 to the x. What's the answer to this no matter what x you plug in?
Itself. 1.
1, right? So it doesn't matter what value I plug into x, it's always just going to be equal to 1.
Got it.
Got it? So
Oh,
1
got it.
to the 8,587, right? That means you're multiplying 1 by itself
Mm-hmm.
8,587 times.
All right. Got
So
it.
1 times 1 times 1 times 1 doesn't matter. It's always going to be equal to 1. So that will explain this magical x that appeared with that 1.
Okay.
So there's the voodoo math there. But
Got
now Are we good?
Yeah, I got it. I don't
Okay.
know.
Oh my God, I don't know. So now it
No, I
doesn't.
got it.
Yeah, well, that's why I want to take a little bit of time on this one.
Okay.
It doesn't matter what direction we go now, right? Whether we look at this way or we look at it this way, right?
Uh-huh.
If we use the exponent rules that we learned in section 4.1, everything still works out. Does that make sense?
Yes.
So if we start at this end, right? We have the rule that the exponent distributes to top and bottom. That's how we get this over that, right?
Yeah.
1 to the x is just 1, right? 1 over the 2 to the x just stayed, right? That moved over. And then if we use our negative rule in reverse, we get that,
Got it.
right?
Yep. Thank you.
Yeah, that was the voodoo math that people always have trouble on. And then if we start over here and go in the other direction, right?
Mm-hmm.
The negative x means I get to do that. 1 over 2 to the positive exponent, right?
Yep.
1 is equal to 1 to the x, no matter what. It doesn't matter what value of x you plug in. 1 to any power is just 1. And then the reverse of the distribution rule, since both of them, the top and the bottom, have a power of the x, I can pull out the x separately.
Got it. Thank you.
Okay. But more importantly, that's just the manipulation of the numbers. Notice what happened between here and here. We now see that this graph, the 1 divided by 2 to the x, is the horizontal flip of 2 to the negative x. So therein lies what I wanted everybody to see, that this function right here, the g to the 1/2, or sorry, the 1/2 to the x, is the flip.
But the x is negative.
Right, when x is negative.
Oh.
So you don't really have to graph, for this one, right? You didn't really have to graph any of the points,
Mm-hmm.
right? So long as you knew what 2 to the x did, you just flipped it.
Yep. Okay.
Okay. I think after this we're done, aren't we? Yep. Okay. So again, we are going to start, for example, 3. We're going to start with 2 to the x, right? The first one's going to be a vertical reflection. So that's going to be this one. 2x, this one's going to have the negative. Got it? So for that one, it's exactly what you think it would be. It'd be the flip. So we know there's a nice point, there's a nice point, there's a nice point. We know what the points are, but we're just going to sort of guesstimate them for our flip. So this point, that one flips. I'm going to put that one down here. So instead of it being positive now, it's negative. Same thing for this one. That's going to just go negative. And then same thing for this one. That's going to go -4. Right? Same thing with the other ones. That one there, one there, that one there. Right? So my final result for this function is going to look something like this. Cool. So I know I muted everybody. You guys can unmute yourselves if you need to. Okay. Moving on to the next one. We are now going to do the horizontal flip, or the horizontal reflection. So actually make that a little smaller. Minus 2 to the x. That was the first one. This one's going to be 2 to the minus x. Right? This one requires the same thing except horizontally across that x-axis. So we have the nice points here, right, that we are now going to flip. Now, this one's a little bit more interesting. This point right here, since we're reflecting it across the y-axis, stays put. But everything else does switch. So then this point right here will go over here. This point right here will flip to the other side right here. And then so on and so forth. That goes right there. And this is the point that I wanted to make from the previous example, that that this thing right here, right, is the reflection, or is exactly 1/2 to the x. So we should be getting the exact same graph from the very beginning of the chapter. From up here, we should be getting exactly this one over here. And lo and behold, we are. So I'm going to use the green marker for this one. It's not very well drawn. Okay. How are we feeling? A fair amount of this must have been a little bit of review, which is okay. Don't worry about it if it isn't. Just, we're going to keep going at it. We're going to hit it hard. Okay. Lecture question. Within the lecture questions, go ahead and take a break. And what I'm going to do is I'm going to unmute everybody so that people can talk if needed. Okay. I think I unmuted everybody.
So, since on this first lecture question, it's 2 to the negative x plus 1, if you wanted to, so an example of this would be like, could you plug in the, where is it, the value of 1 on the x axis and then solve for that? Like, what exactly would you do to like kind of start that off?
So what's that negative x do? What's that negative in front of the x do?
It flips it, correct?
Which direction? Vertically or horizontally?
Horizontally.
Right. So you're going to have something that actually looks like this, right?
Yes.
It's like
The left one?
right.
Oh, the right one, excuse me.
Yeah, the right one. You're going to have something that looks like that, and then what's the plus 1 do?
The plus 1 would make it to go up.
Right. And see how that works out?
Yeah. So would I So essentially, could you go? Actually, let me go back up to that one. So do you just pull values from like just anywhere on here and then just solve for that?
You can do it by points, but so you remember when we were doing transformations from the very get-go of the semester, you were able to look at specific things that happened within the function itself, right? And based off of those things, you can graph the function itself. So you remember when I made you do like x plus 1 squared minus 2. So then that plus 1 did something specific and that minus 2 did something specific, right?
Yeah.
Just how in this case, that negative does something specific and that plus 1 does something specific. So the better way, you can do it by points. So if you want to say something along the lines of like, if this is 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, and graph it that way, that's perfectly fine. But I'm saying like sort of, I think the easier way is to see what each one of these things are doing, right? Graph the base one and then move it as you need.
So it looks like you put the plus 1 in the parentheses and then you put the 2 outside.
Right, for this one.
Now, wouldn't that signify that the negative 2 is the y and then the 1 is the x?
Exactly. So remember back in the day, this meant a horizontal shift. You were moving it left to right.
Yeah.
Right. And then this told you a vertical shift. It's going to tell you to move it up or down.
So here it's switched.
No, it's the same thing. So what's that plus 1 do?
It moves up.
It moves up by 1. And then that negative x is going to do what?
You're going to move it over to the right or left.
Not a move.
It's going to become, will it become a positive though? Because you have a negative there now, but like usually you do the math work and then it become a positive, wouldn't it? So like if you had 2 to the negative 2 negative squared up there, wouldn't it become 2 squared and then 1 over 4?
Right.
I don't-
So technically, so remember, this is the thing that, let me actually zoom out a little bit. I want to go back up to this thing. So remember when I did this thing?
Yeah, it's the same thing down there, correct?
Right. So back in the day, this thing, this plus or minus, we didn't do too much with it. Right?
Yeah, and that's from like 3.6, 3.7, right?
Right, exactly. For this chapter, it has much more significance because you can actually flip it and it'll actually do something. So the reason why this was not too big of a deal before was because we were messing with parabolas, right?
Yeah.
V shapes. Does that make sense?
Yeah.
So a horizontal flip meant you had to go like this, right? You had to sort of rotate them that way, but they're the same shape either which way you flip them. So that's why this didn't matter much back then. Now it does.
So now going back down to the example for that problem. So in order to do this, so you said not to plug in the points, or you can, but there's a alternative way that's better. And it was the way you just showed on the bottom in that little box.
Right.
So when you do that, so you did x plus 1 squared in those parentheses, and then there was a a positive 2 that you put right
Mhm.
next to it. So
This, right? X minus 1 squared, or no, plus 1 squared minus 2, I think I said.
so would that give you the point at -2, and then I'm just confused because I'm so used to seeing that +1 where the -2 is.
Mm-hmm.
So
You're talking about
you're
this
you
plus 1.
yeah, so you're still using that +1 to move up. It's not gonna go left or right. It's gonna go up still.
Right. So let me actually put you down to, I think I gave so here, yeah, ha ha ha. This one has a -2, right?
Yeah,
This is one of those shifts that go
left or right.
Uh, this 2 that's right here, right, or this -2 that's right here, that's going to be one of those shifts left right, as opposed to like right next to it there's a +3. That's a shift up down.
Okay.
I think that's what you were getting at.
Yeah. Okay. So that actually does make
Okay.
sense.
For this one, pretend that's the parenthesis, right?
Okay.
So the -2 is with the x. When over here, for the one next to it, it's not with the x, it's actually separated away.
Okay. Now that I know those things, how would I start the problem? So, going back to the first one, I got 2 minus x. So would I plug 1 into that minus x and then solve for that to get my final answer?
How about graphing this one first? Graphing the base function, so 2 to the x. Just graph those.
Calling all the Louis Vuitton lovers.
Let's try this out.
Your newest.
I think
someone's watching a video.
Yeah.
Okay.
Part-tip redact. What? A part-tip redact scabber. What are you talking
I think they forgot their mics on.
Yeah. I knew this was going to happen, so that's okay. Let's see. Oh, I shouldn't turn on my video. Well, can people still see my screen if I do this? Yeah, right?
Yeah, I can still see
Yeah.
it.
Okay, good. Like I said, break time. Somewhere in there, take yourselves a break. Like I am. I'm gonna go use the little boys' room. I'll be back. I'm gonna mute myself so nobody can hear me tinkle. I'll be back.
You got it.
Graph.
All right. Does this chapter make sense?
Yes and no.
Yeah, and I figured the no's. Somebody was bound to say no, and this is a difficult chapter, even though a lot of it is review. It's practicing with it. So
It's like incorporating it
yeah,
in itself.
I feel like I understand it. I feel like, would you mind just running through the first lecture question just so I can get like an idea, so I can just kind of go back to like the second or third one and kind of trace back what I did on that first one?
Fair enough. You can do
Usually seeing something like that I can go back to and just kind of relate to other problems helps out.
that. Right. So let's go. Let me turn my camera off again.
So that I feel like the y would be on, or the x would be on 1, because if the graph was like that, I feel like the HA, or the horizontal asymptote, will be on 1, and y equals 1. It should be there.
You are exactly correct. So I'm going to graph the base one really quick, right? So we know that it does here, 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 and then a half, a quarter, a third. So the original function,
And it's flipped from that.
right? So this is my original, right? Cool.
Yeah.
Let's do the, so remember how I think I put it on a previous, where can I write it? I'm going to write it up here. I did it in a previous, section, right? You would want to, how did it go? So the first one, you would want to compress. Whatever compressions happen, make it happen first. After that, do the flips. And after that, do the shifts. Right? So here is the initial function, right? So all of it is based off of this one right here, right? And that's the one that I just graphed, that one. Cool?
Yeah.
Somebody's got some classical music
Playing in the background.
Yeah. This is not bad.
I don't even know who that's coming from. I don't see any mics moving.
Yeah, that's okay. So then now we do so the very first thing that's sort of requested here is the flip. Since there was no compression, we're going to do the flip. That basically means everything gets flipped. This point right here
goes up.
No, that point well, let's just go ahead and do the flip first. We'll do the shift afterwards. This point stays put, but everything else flips to the other end. Does that make sense?
Yeah.
Cool?
Yeah.
I'm not going to connect the dots yet because now we're going to do the shift upward. And that I'm going to do in red. So this is going to be the final. And the +1 does what?
The +1. Oh, I'm just writing the graph down just to get the points correctly. 1 second.
Doesn't it move it up 1?
It moves everything up 1, right? So
Yeah.
this one goes here, 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 here. You guys got it? And if we connect the dots,
Right on the 1.
exactly where you said they would be, Hunter. Right? So originally the asymptote was right here. What should the +1 have done?
+1 should have raised it up 1 from its original point, so
Right.
it would be 1 in between.
Yep. So that gap right there is +1.
So honestly, you don't have to do like all the work technically. You can kind of just run through it honestly and just, like you said, compress, flip, and shift.
Right.
really
And
quickly.
right, and that's the point. So remember how this worked out what, maybe about a month ago, right?
Yeah.
I gave you guys a graph. I gave you guys a graph, and you knew exactly what it was going to do. It was going to either shift left, right, up, down, flip. It's supposed to be that way.
Yeah.
Yeah. All right. Oh, how about this? We haven't finished it yet. What's the domain and range? So how about this? There were three other things: horizontal asymptote, domain, and range. So my horizontal asymptote is where?
1.
Right. So y is 1. So horizontal asymptote is done. Domain.
The domain would be it'd be from, so it's at, you need the vertical S. No, you don't. This is the domain.
Yep.
Would it be negative infinity to positive infinity?
Right. So let me run down the logic there. What are the two things we can't do in math?
We cannot subtract a square root, and we cannot multiply or divide by 0. Is that what it is?
Divide. Oh, close. You can't divide by 0. You can't take the square root of a negative.
That's what it is. I was close. I was
Right,
just,
you were. Does it look like we're doing either one of those things in our functions there?
I don't believe so, no.
Mm-mm. There's no division there, and there's no square root anywhere, so we're golden.
And the range would be from, would it be from, it'd be infinity. What's the first number though?
Yeah.
It would be 1 to infinity, right?
Yeah, that sounds right to me.
Do we include one or do we not include one?
Not include 1.
Not include one. You guys are feeling good about this. This is pretty good, yo.
So what I'm still confused about is I just don't know how to get the points. That's just, so you kind of just raised up 1 for each one. Is that basically what you were doing because of that plus 1? So you went up literally on 0 on the x-axis, up 1, and then you do like went left up 1, left up 2.
Right. So I was doing it based off of these points. So let me zoom in. I was doing it based off of these points right here. Trying to find a good color for it. Let me see. No, the blue. So I was doing it based off of the original points for the original graph. So that blue, that one.
And where'd you get those original points from? The 2 negative x?
That is, so each one of those
Our
points.
toolkit functions. Is that our toolkit functions?
Not yet.
No. Oh, not yet.
So
Okay.
what I'm going to do is, I wanted to present this first
Uh-huh.
to get you guys used to it because it generalizes. I need to make a general toolkit function for you guys.
Okay.
So there's going to be one for this, for exponents, and there's going to be one for logs,
Oh, okay.
which is going to happen in the next chapter. Well, in section 4.4, actually.
Okay.
Yeah, I know.
My brain hurts.
I know. So Hunter, to answer your question, so those blue points I got from the original, the OG vanilla function,
2x.
2 to the x. So I graphed those points, and those got me those blue ones. That one, that one.
And when you're like on a test, what would you graph with your calculator basically, or what would you graph it with?
You can graph it with your calculator. That sounds fine. If anything, I can give you guys the base function, and you will be expected to know what the changes do. Does that make sense?
Okay, so that thing that you're going to give us will basically tell us what the points are, but we just got to figure out the rest of it, basically.
Right.
Okay, that Lou sounds perfectly fine. I can do that easily.
Yeah. No. My pen is clumsy. I wanted to erase the.
And you could rewatch these lectures, right, on this application.
So I haven't figured that part out yet. I'm trying to make it so that let me fix up the thing that I just screwed up. I'm trying to see, because I have the lectures already. They're already in video format. The issue is how I give them to you guys.
Okay.
Put them up on YouTube.
So a fair amount of the other instructors have been putting their stuff up on YouTube.
Yeah.
So if yeah, I'm trying to put them on Canvas. I'd rather they be on Canvas rather than an outside thing. Does that make sense?
Yeah.
Yeah, but why? I feel like this is hella helpful.
I know.
Everyone
I know. Well, I mean,
in the world.
I would, right. I think I would. I want to give it to you guys, sort of. Not, I don't want to say like exclusively, but my obligation is to give it to you guys, right? And I want to do that sort of. I don't want to add in. How did I say this? The college is not, doesn't technologically support having YouTube. Does that make sense? Now, I don't, the way I say that is the platform that the college uses, right, has no support for the applications that YouTube uses. Does that make sense?
Yeah.
So if I start providing stuff through YouTube, that's adding in a third group, a third thing.
Yeah.
Does that make sense? That the college technically does not support. I'm trying to avoid that.
Okay.
I see what you mean.
So that it be still available for you guys, and the college is still obligated to sort of maintain it. Does that make sense?
Yep.
The college is under no obligation to maintain anything that comes from YouTube.
Okay.
You see what I'm saying? So that's why I kind of want to see if I can add it to your Canvas pages at the bare minimum. If not, then I'll have to create a YouTube account, and then I'll put all that stuff in, and then, you know, whatever happens, happens. Yeah.
Plus, we can be more interactive here. At least we don't have to go to like our Canvas app just to like comment to each other on the video.
That is true.
Yeah. So yeah, that's my spiel for that.
That shouldn't be too bad.
All
And
right.
do you know when we'll get that toolkit function so we can start doing these? Like make it.
I've already have it written. I just need to clean it up a little bit. That's
Okay,
it.
no problem. No problem at all.
I gave you guys ones for, what did I give you guys ones for? For the regular functions, right? But the current one, so I'm sort of changing up ones that I've already done from before. I need to add in some tables, add in some points to make it a little bit more clear. That's it.
No problem.
Whew. Coffee's wearing off.
I believe it. I believe it.
Yeah. Everybody else doing all right? I know you guys are all muted. Bryce,
Is this part of our break or no?
Jarek, huh?
Were we supposed to be taking a break this whole time?
I was gonna start the next section at around maybe 11:15 about.
That's perfect.
Okay, perfect.
So, like I said, this is your guys' lecture hour, or the lecture question time. Try to do as many of them as possible. I'm still online, just how I would be, like in class, answering questions. somewhere in there, take yourselves a break. Go step away. Hell, I should put cartoons on. To force people to watch cartoons.
Put on Tom and Jerry.
Oh no! Well, that is a good idea. However, I think I might have another. Let's see. Yeah, you guys keep doing your thing. I'm gonna